So maybe just to kind of start, what maybe prompted the development of the ZQuip system?
Right. So ZQuip came about from years of Moog working in growth and innovation spaces and in the construction sector. A lot of our work originally was in the space for actuation and motion control in construction. We started working with Bobcat and Komatsu and Case. ZQuip came about as a result of what we learned in those early days of electrification, and it was our desire to sort of put our own stamp on the industry, to move in a way that we thought was different but better. And it also was, we just saw the pace of change happening in the industry, and we thought we could do more to help, right? And we thought we could do things that would accelerate the adoption and the innovation in the electrification space. And ZQuip is what resulted in that.
Mhm. So maybe could you provide an overview of the system and the various technologies that it includes?
The overview is that ZQuip is a modular solution for the conversion of diesel machines to electric. The whole idea with ZQuip is that it allows customers who need to go electric a productive, economic way to do so. It really is our vision of how we think electrification should happen, right? The modularity of the system helps the uptime, the serviceability, a lot of the key detriments we've seen in electrification and the limiting factors to people wanting to adopt. We overcame that by this solution that we think meets the needs of customers. ZQuip is the way that we think the industry needs to evolve in order for all of the investment and all of the work that's going into electrification to be adopted as a whole, right? There's so much time and money going into this, but if you don't approach it with a standard, an ecosystem approach, we don't believe that it's going to really meet the needs of customers. And so our hope in ZQuip is that this approach to meeting the needs of a customer, getting their machines electrified in a way that allows them to get all the work done that they need at a cost that makes sense to them, that this is how we can accelerate.
So when we started this whole adventure, I come out of a construction background. So before I came to work for Moog, I owned a construction company. Some of the other engineers came out of the automotive industry. So when we first got together, we were looking at this problem very differently. I was looking at it from how are construction people motivated to get their work done every day on a site. They were looking at it from a point of view, well, you can just kind of plug it in and come back the next day. That's an unsatisfying answer for a construction person. They're determined to get their work done.
Mm-hmm.
So we kind of argued about that for a while, and we realized we really could do both. We could have the fast charge capability, which is awesome, but we could also do battery swapping and sharing energy across machines. So that really turned out to be, really, once we had that established, everything else fell into place pretty easily.
And so as you guys were developing the ZQuip system, what were maybe some of the what are some of the factors that had to be considered, challenges faced, and maybe how did you go about overcoming those to ensure the system would meet the needs of the construction equipment industry?
The number one most important thing was to make sure that we were really paying attention to the complexity and variety of construction sites out there. Sometimes you're working in the city and you have good grid power, other times you don't. And so really stepping back from, engineers love to dive into the technical, right? That's what we do. But we had to really step back from that and understand what all those challenges are, weather and access to power and different operators. Once we kind of wrapped ourselves around what all the requirements of the system were, everything else came together pretty easily. The technology, we had to develop some of it for sure. A lot of it, because where the automotive industry is going, was out there. Some of it doesn't exactly cross over, so we had to develop some things too. But once we understood what we were trying to accomplish, it was pretty straightforward to get it done.
What are one of the more unique things you had to design for the construction industry versus what might be done in the automotive?
Okay, sure. So in the automotive industry, they're totally focused on integrated batteries in vehicles. So they're either fast charging or level 2 charging. And that works pretty well because the car has a long range on the battery that can reasonably be integrated into a car. That's less true of construction equipment. So we had to deal with the fact that sometimes you're going to fast charge, but other times you're going to swap batteries. So you're going to actually remove them from the machine and put other ones on. You need to be able to do that with these batteries that are substantial. Our typical battery is roughly double what a typical EV carries. Okay, and we might use 5 of those batteries or 6 of those batteries on a machine. Kind of gets you an idea what we're talking about in terms of energy. You're talking about 10 cars worth of energy on a typical 20-ton excavator. So we had to develop the ability to get those batteries on and off the machine, make all the connections. That's mechanical, that's thermal, that's communication, high voltage, all the different things to make that all work. And then even beyond that was being able to transfer energy from machine to machine, which turns out to be a really critical portion of the ConOps, to be able to take energy out of an excavator and put it into a CTL or vice versa and be able to move that around the site. When you get to the site logistics, being able to go from any machine to any machine, moving that energy is a big deal. That's what makes it possible to have an all-electric site.
And that was the evolution of thought from one machine to one site to an entire fleet was really when the light bulb started going off for us, right? You can talk about a lot of what could happen. Right? Is battery going to be the way? Is hydrogen going to be the way? Is hybrid going to be the way? Nobody knows. Everybody can have an opinion, but nobody knows. But what we did know, when I talked about really having to look at this from an ecosystem, the economics and the operations are so different when you go zero emission. One of the things we saw happening in the industry that we thought was wrong is trying to put smart zero emission super machines onto a site in place of a diesel machine and expecting it to work properly. It's not the same, right? You're replacing a rotary phone with an iPhone. You can't use it the same. And so when you start to look at it differently and you see the ConOps that go into it in the planning, if you don't take into account how that affects your day-to-day operations, you're going to be disappointed. Now, we saw that when one of the first times we rented an electric machine just to test it out, and the rental company dropped it off and said, we don't know how to use this. Good luck. Right? A horrible experience. And it's not the owner's fault. It's nobody's fault in one individual way, but it ignored the reality of what this change is. And so by looking at this in a way where you don't need a zero emission machine, and if that's all you need, we're not for you. But if you're looking to really make a change and you're looking to be the early adopter and the innovator on zero emission and get ahead of the curve, you really are making that investment in how it works. And so if you think about ZQuip in that sense, our batteries are interchangeable across all ZQuip machines. You can have an excavator, a wheel loader, a dozer, anything that takes ZQuip. The conversion is separate from the battery. And so that was another key part is really being conscious of having a machine that is able to take a battery is different from an electric machine, right? It's the analogy of the bare tool and the battery. What we are trying to create for construction machinery is a site and a fleet full of bare tools, just drills and saws and all of that. That all can take the same batteries, but that can take the same batteries across OEMs and across sizes. And so if we can make a site where your machines operate just like all of your hand tools, but all your batteries work across them, they all communicate with each other, and we provide a layer of service over that in software and planning, because it is difficult to plan ahead for and account for, when do I charge this? How long do I have to charge it? What could go wrong that will change my day? And really, it's what can go wrong that's going to screw up my job. And right now, they don't take that into consideration. And I say they as in everybody. And we've been a part of that too. This isn't a pointing a finger. We just really believe that in order for this to work, you have to start with, you just have to get a lot of work done. We cannot sacrifice the work. So starting with that and working backwards, it's, Rob coming from a construction background, what do you want your day to look like? And if we could snap our fingers and have a world of electric machines, what would it be?
Again, I came out of the construction background, and when you start looking at these machines and how much energy is involved and the size of the batteries required and how a machine might want to work, we looked at sites that are fixed-based operations that run 24 hours a day, like, waste transfer, these kind of things. What you realize is that there isn't a right size or right battery to load onto a machine. It depends on the work that needs to be done that day. Sometimes you use the machine all day, other times you don't. So whether you have too little battery or too much, they're both bad. Being able to have the right amount on the machine for that day. And, Chris alluded to planning. For sure, there's planning involved in doing all this, but a plan, they don't always go exactly as they should. Sometimes they go sideways. And so you got to put the batteries around and move the energy around. That's the swapping, the fast charging, and the machine-to-machine transfer. And so being able to give you all those options for the day so that you can prioritize, make decisions, plan for extra energy, plan to not use your energy available. You can rent out your modules someplace else. You can use them on a different site, use them on an alternate machine, figure that all out. That level of flexibility is just unheard of in this world.